Hi, I'm Avram Blum, Chief Academic Officer at TTIC. I'm very proud of all the fantastic research going on here, some of which you'll be hearing about straight from the researchers themselves in this video. TTIC is a standalone computer science graduate institute. We have 12 tenure-track faculty, 12 short-term research assistant professors, and 45 PhD students, working on a broad range of areas, including machine learning, theoretical computer science, natural language processing, speech recognition, computer vision, robotics, and computational biology. We're affiliated with the University of Chicago and supported by a generous endowment provided by TTI Japan and the Toyota Company. I encourage you to attend some of our many virtual scientific events and to come visit us once the situation permits it. And I hope you enjoy this video.
My name is Audrey Siddell. I am currently a research assistant professor at TTIC. My area of study is soft robotics.
I'm Frida. I'm a third-year PhD student at TTIC. I'm very fortunate to work with Professors Karen Levescu and Kevin Gimple on natural language processing.
So I'm Julia Chijoy. I'm a professor at TTIC. I've been with TTIC for a long time, I think around 13 years, and my research area is theoretical computer science.
Hi, I'm Sapida. I'm a research assistant professor at TTIC. I did my PhD at MIT and then a 1 year of postdoc at Columbia University. And I do theoretical computer science.
Hi, I'm Han Shao. Currently, I am a second-year PhD student at TTIC. I work with Professor Avram Blum. I'm interested in machine learning theory.
Hi, my name is Lingyu Gao. I'm a fourth-year PhD student in TTIC, and I'm working on natural language processing with Kevin.
I'm Kavya. I'm a first-year PhD student at TTIC, and I work broadly on theoretical computer science and theoretical machine learning.
My name is Karen Levescu. I'm an associate professor at TTIC. I've been here since 2008, and my research is on speech and language and related problems in machine learning.
My name is Mina Karzant. I'm a research assistant professor at TTIC, and I work on theoretical aspects of machine learning through interdisciplinary approaches such as computer science, statistics, and engineering.
Hi, my name is Agita Pasad. I am currently in my fourth year of PhD, and I'm fortunate to be working with Professor Karen Levescu here at the Toyota Technological Institute at Chicago.
My name is Allison Ettinger. I'm an assistant professor of linguistics and courtesy faculty at TTIC, and I do research in computational linguistics.
I'm most interested in solving problems related to human language with computational techniques. So on the one hand, I discover facts about human language with computational toolkits. And on the other hand, I apply the discovered facts and design and implement algorithms to enable machine understanding of human language.
What's interesting to me about soft robotics is that it falls at the intersection of many different areas: computer science, material science, and engineering.
Currently, I'm most interested in statistical learning theory. I like seeing different complexity measures for different learning problems and how they affected the theoretical results.
So I'm interested in solving problems that have clear applications, even if it's only in the long term, but also that have a technical challenge that's more general than any one particular application.
The problems that I am most interested in are problems involving trying to understand how the human brain extracts meaning from language and how we can try to engineer those same kinds of processes in artificial intelligence.
So I have a little bit crazy story about this. I grew up in Soviet Union, and I think personal computers did not come to Soviet Union until much later. So I haven't seen or touched the computer until I was around 19. And so when I was little and I was not sure what I want to be when I grow up, my mom told me that if I'm into mathematics, I should look into computer science and computer programming. I asked her what are computers, and she told me that these are machines that can think on their own. So to me, this was such an amazing and fascinating notion that I was completely sold. And this is how I knew that I'm going to study computer science.
I became interested in theoretical computer science when I was at high school, and I was involved in computing Olympiads. I enjoy designing algorithms, and that's why I still do them. But more broadly, I'm interested in problems that are challenging theoretically, but at the same time have real-world applications.
I became a computer scientist because as a kid, I really enjoyed discrete math, and I wanted to try to solve problems that I saw in the real world using discrete math, and abstract these problems and formalize them, solve them, and then apply my solutions back into the real world domain.
I found my interest gradually in the past several years. I used to major in electronic engineering during my undergraduate. But I found that I'm not interested in semiconductors or circuits, and at that time I was taking algorithm class. I found algorithms are really interesting to me, so I decided to transfer to computer science. And during my master's study, I started to work on some online learning problems and found my interest in machine learning theory.
I think it is useful or interesting to work on NLP because I think it could save human efforts with these automatic models. Also, they could uncover deep buried features hard to tell by human beings. And also, it could improve humans' life quality with the real applicational use. I think it is good to work on this because it is a very broad area. There's so much that we don't know, and there's so much to learn for me, and it would be great.
My work is focused on designing provably optimal, statistically and computationally efficient learning algorithms in various setups, such as learning graphical models or designing recommendation systems. I mostly look into setups in which learning the exact and accurate structure in the datasets is not only unnecessary, but also wasteful.
My current work is focused on developing self-supervised algorithms to learn speech representations from unlabeled data that not only ease the labeling requirement for downstream tasks, but are also more than just a vector of floating point numbers. So we are trying to design the model so that these representations are interpretable to have some form of meaning, which could also enable us to utilize these more efficiently with the downstream tasks.
I chose my research area because I've always been interested in language. My earliest areas of expertise were in linguistics, psychology, and cognitive neuroscience. But after I took a computational linguistics class, I realized that I could also tackle interesting puzzles relating to language while also having impacts on downstream applications. So now I do work that connects both of these threads, linking the study of human cognition to natural language processing and also using computational models to understand how language works in humans.
The thing I enjoy most about my research is working across areas, including design, control, and morphological intelligence. It's exciting to create robots that can both think and act.
I enjoy discovering facts about natural language, and it's really exciting to discover correlations between two seemingly irrelevant terms. So, for example, my work shows there's some correlation between concreteness and syntax.
So the part that I enjoy the most is actually just sitting and thinking about problems. So I like to think about a problem consistently every day, maybe for an hour or two. And I like how slowly, day by day, maybe even months by months, you feel that you sort of start understanding the problem better and better and better. And then if you're lucky, sometimes you get this amazing moment where everything falls into place and suddenly you just get it and you solve the problem. It doesn't always happen, but when it does, it's really great. And I also really enjoy watching students, how they gradually grow into mature scientists and how they also learn to enjoy their research.
The most exciting part for me is finding the solution to a technical question or finding another view of the problem.
It's a little bit hard to say what I enjoy most because I really enjoy a lot of things about it. But one thing I especially enjoy that's a little bit unique to this kind of work, especially in an academic setting, is working with people in many different stages of their careers, including students and postdocs and research faculty and tenure track faculty. And it's very rewarding to be able to teach and mentor students and others who are younger than me, but actually everyone is learning from everyone else, both more senior and more junior. And I think that's just a very intellectually stimulating environment.
What I enjoy most about my job is that I get to engage with interesting ideas and be intellectually stimulated. I get to be around smart and curious people all the time, and I love that my job is to try to contribute more to what we know about the world and what we can build.
Hi, my name is Matthew Turk, and I'm the president of TTIC. I'm very happy to be celebrating the 6th annual International Day of Women and Girls in Science with you. I think it's important to note that despite huge inequities that they've had to face, there have been many courageous and accomplished women over the years who have overcome big odds to pursue interests in science and contribute in all kinds of ways, including women who've made really major contributions, some who are very well known. Women like Ada Lovelace, Marie Curie, Barbara McClintock, Grace Hopper, Rachel Carlson, Katherine Johnson, Diane Fossey, Jane Goodall, Turing Award winners Frances Allen, Barbara Liskov, and Shafi Goldwasser. And importantly, many, many more who are not so well known, but who've helped pave the way for women today. At TTIC, we want to celebrate the rich opportunity of all women involved in science. We want everyone to have the same opportunities, which means equality in education, cultural expectations, the availability of mentors and role models, and of course, job and career opportunities. To achieve this, we have to continue working to eliminate bias and to encourage more young girls and women to feel like they fully belong to the scientific endeavor and the scientific community. TTIC is committed to these goals and to strongly supporting women. We have great, highly accomplished women here among our faculty, staff, and students, and we very much welcome others who want to be in a place that both challenges and supports them. So again, on behalf of TTIC, I'm very happy to be celebrating the International Day of Women and Girls in Science, and I hope we can all learn and gain from this day. Thank you.